Okay, so today, what I want to talk about specifically is inequalities. Inequalities. Okay, we're going to see two types today. We're going to be basically solving for x, solving an equation, and we're going to be looking at graphs. Okay, and the graphs are on the back. Okay, so solving equations are on the front. It is 4, 16, 18. So we'll look at first solving for x on the front. And this is the exact same problem I did on Friday, but I wanted to do it again so you see how it works, okay? Before I do anything on example 1, what I know for sure is I can't have the square root of a negative number, okay? Can't have it, right? Pretty good with that? So when I do these problems, I know that I can solve for x. I can square both sides, subtract 4, divide by 2. I can solve for x. That's easy. But our answer that we're going to get, square, right? Solving, right? Let's just solve it. We get 2x plus 4 less than or equal to 16, right? Minus 4 minus 4, 2x less than or equal to 12. Divide by 2, x is less than or equal to 6. That's only half the answer. That's correct, but there's more. That's only half the answer. Because we know, just on a side note, we know that if x equaled -3, it won't work. It won't work. So, think about this. X is less than 6. That would include -3. X is less than 6 would be 5, 4, 3, 2, 1, -3, -2, -1. Now how do I know x can't equal -3? Well, let's check it out. If I put -3 in here, right? I'd have 2 times -3 is -6, plus 4 is -2. You can't take the square of it. So this answer is only partially correct. There are some answers that we can't use. So what we know is that what's inside of here must stay positive. So the second half of us say, well, wait a minute. Let's sure we take 2x plus 4, and we make sure it's greater than or equal to 0. So what's inside has to always be 0 or more. 0 is okay. Square root of 0 is 0. And positive numbers, right? So what x values make sure that we're always going to make sure we have a positive value inside our square root. So we'll solve. We'll solve this. So, okay, minus 4. 2x is greater than or equal to -4. Divide by 2, x is greater than or equal to -2. So what we have is a range of values. For this to be true, we have a range of values. Our values have to be greater than or equal to -2, but less than or equal to -6. So in set form, I'd go -2 is less than or equal to x, which is less than or equal to 6. Okay? That would be the value of x. Because we know that if we are at -3, it won't work. We want everything greater than or equal to -2 and less than or equal to -6. Now, on Friday, I even graphed it for you so you can see it, right? On Friday, I even graphed it. So if I went through and put it on my calculator, okay, clear this, and if I went the original square root of 2x plus 4, right? And I graphed the value of 4. Let me change my window so it'll work. 4. So I've got two graphs. I've got the square root of 2x plus 4, and I've got the value of 4, okay? And I want to find out when is this graph less than 4, okay? So let me change my window real quickly. -5 to, let me make this about an 8, and probably a -1 to probably a value of, let's see, if I plug in 6, let's try 10, okay? Let's graph this, okay? So here's another illustration of it graphically, okay? So, when is this graph less than 4? Which shows it. Here's your square root graph. When is it less than 4? Well, it starts here, right? You can't have any values back here. That's this piece. You see, if you look at this piece right here, x has to be greater than -2 because it doesn't exist back here. And right here, it is no longer less than 4. It's above it, isn't it? So it's just within just this spread, just within this range that we get all our values. Sure enough, it's between negative 2 and 6. Sure enough, it's between negative 2 and 6. Those are when the graph is less than or equal to 4. Okay, let's take a look at number 2. Number 2 is the same type of problem. We'll go minus 3, minus 3. So it's the same problem, right? Minus 2, sorry, thank you. Minus 2, thanks, Katie. Square root of x minus 3 is less than or equal to 3, right? So let's just solve like we normally do. Square both sides, x minus 3 is less than or equal to 9, right? Plus 3, right? We get x is less than or equal to 12. But that's only half of the problem. I do know, just looking here, that if x were 3, we'd be okay. If x were 3, we'd be okay. But if x were 2, we'd be in trouble. If x were 2, we'd be in trouble because 2 minus 3 is a negative 1. So I don't even try and guess this. I just say, okay, well, the other part is to say what's inside the square root. Okay, so the other half is what's inside the square root must always be positive, right? What's inside the square root has to always be positive because that way you get positive values. So let's just take what's inside and make it greater than or equal to 0 and solve. Plus 3. So my values of x have got to be between 3 and 12. Any other values won't work. It's because of the inequality. So I can say, okay, well, 3 is less than or equal to x, which is less than or equal to 12, is my answer. And again, I could graph it and see it if I wanted to, but I'm not going to because we did that on the last one. Okay? So when you get an inequality, you've got to be careful with square roots because you cannot have negative values. If I went straight to what was less than 12, that's a lot of numbers. Am I making any sense? Okay, turn the page. Okay, now.
Wait, example 3.
Oh, I forgot example 3. Thanks, guys. Now, what do you see about example 3? It's a cube root, okay? If it's a cube root, we learned a couple of days ago that cube root graphs look like this, right? That's a cube root graph, and we learned that they can have negative values, right? And if I look at the domain of this, it's all real numbers. The domain of this graph is x equals all real numbers, okay? So if it's all real numbers, then any value can work. So we don't need to worry about any exceptions. We're just going to graph this, okay? Everything will work. All things work. So I'll just go cube it, because that will get rid of the cube root. X plus 2 is greater than or equal to 1. Minus 2, x is greater than or equal to negative 1. Even though that is a negative value, that is okay. That's okay, right? You can have negative values with cube roots, okay? Okay, you guys ready to turn the page? Now, there are 2 ways to do this one, okay? And I'm going to do both, and then we're going to let the calculator do both, okay? So, first of all, I know the end point is at negative 1, negative 3, okay? Right? And I know it's a square root graph. We looked at square root graphs the other day, and the parent function square root graphs look like that. Remember that? How square root graphs look like that? We used values. We let x equal 0, 1, 4, and 9. Right? We use those values for x because...
We can't see.
Oh, sorry. We use those values for x because we can take this square root of 0, square root of 1, square root of 4, and square root of 9, right? So, from here, if I go over 1, the square root of 1 is 1. If I go over 1, 2, 3, 4, square root of 4 is 2. And if I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 3. So my graph should look like this. However, we want all values of y. We want all values of y that are less than that graph. Okay? So we're going to shade. We're going to shade. Well, if it's less than, don't we shade below, right? We shade below. With one small exception, we've got to be careful in that we don't shade anything over here. We don't shade anything over here. So we shade everything below, right? Now, our calculators can shade for us. They really can. So if we go to our calculator, I'm going to type this in. Okay, one of the things I need to do when I do my calculator, let's see if I can put that where you can see it. Everybody see that? There you go. Great, clear. I'm going to type in my square root of x plus 1, right? Subtract 3, okay? Now I can shade by taking the, over here, see, okay, watch. Okay, I'm going to go through this slowly. That is dark line. I don't want a dark line. That is greater than. That is greater than. That is less than. That's a funny little dot, 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 circle, open circle, but we don't want that. That's another 0, 0, 0, but they're not connected. So it gives you lots of weird ways to draw lines, right? But, and I don't need a dashed line, right? But it will do a dashed line, isn't that crazy? What I really want is that one, because it's less than, right? You guys agree? Now let me check my window. So the window I need is one that's going to fit on my graph. The window I have here is really from, well, I can go -5 to 5 probably. -5 to 5 will probably work. And the window here is probably, oh, let's go maybe negative, I don't know, maybe -5 to 5 on that one. So just make my window work. -5 to 5. And if I graph this, let's see what it looks like. Exactly like I just did. Isn't that cool? Isn't that cool? So let the technology do it for us. Sweet. Right? Okay. Shift to the last one. Now, this last one, we haven't done these for a while, but a long time ago we talked about these kind of graphs, all right? And if I graphed 1 over x, we saw that the graph looks like this. I'll show you. And this is a parent function. We saw this a long time ago, okay? Remember that? That's our parent function, right? And we have asymptotes at x equals 0, and we had asymptotes at y equals 0, right? Remember we were doing that a long time ago? So we have the same parent function, except we're going to move this center to, so we move this center to the value of 2, -2, okay? 1, 2, and 1, 2, okay? 2, -2. And that's where my asymptotes go, right? And we don't have to be perfect when we sketch it in. We just want to get this shape here, right? So I'm going to go ahead and sketch it in, right? So it looks something like this, okay? Now, there are two ways to do this. The hard way, I'll show you real quickly, and don't write this down. The hard way is, you know, you're going to shade. You got to shade, right? Maybe here, maybe in here, maybe here, maybe you're not sure where to shade. So one of the things you can do is you can pick a point, okay? The easiest point is 0, 0, and you plug it in, okay? This is, we're not going to do this. So let's say I pick 0, 0. So okay, 0 is less than or equal to 1 over 0 minus 2 minus 2. So I get 0 is less than or equal to -1/2 minus 2. Is 0 less than -2.5? So I'm probably not going to shade 0, 0, right? Now I can test every region, but you know it's going to be easier. Let calculator do it. So if we let our calculator do it, right? Clear. I'm going to go 1 divided by parentheses. Thanks, Katie. 1 divided by parentheses x, subtract 2, and then I'm going to go a plus 2, right? Nope, subtract 2. My bad. Subtract 2, okay? Now if I want to shade, right? I go over here on shade and make it not that one. Not that one. But I want less than, so I want that one, right? I want that one, right? And if I push graph, cool, look at that.
Would you look at those?
And sure enough, 0, 0, 0, 0 didn't get shaded, did it?
No.
So back when I was a kid, we had to test every region. What a drag. But you guys don't have to, because you just get to put on the calculator and shade. So where's my answer? Yeah. So my answer is going to be here, right? All of this, right? And then all of this. I'll show you again. I will show you again. Hold on. Okay. All of that and all of that. So Renee, when I went back to my y equals, okay? So you move the cursor beyond the equal sign, right over there. See how it's flashing? That's the under triangle, which that's the lesson. Let me go through them again. Okay, enter, 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 enter. That's greater than. See how that's greater than? Because you've got the triangle above, and that's less than.
What was the window that you put in?
Here's my window. And Katie, you know how I think about the window? Is if I draw it by hand first, it gives me an idea what my window should be. Does that make sense? Right? In just a sec, okay? And so then I push graph and I got it, okay? So homework, you guys. We have plenty of time to do it. All right. Renee, go ahead. Make it quick, please. Page. I got two different pages because I got two different types of assignments going on. So we got lots of time. Page 625 and page 632. And I'm going to